Good morning, everybody, and welcome to the digestive system. The digestive system is way more than a digestive system. It's a system of compaction, it's a system of absorption, it's a system of distribution, it's a system of excretion. So, why do they only call it the digestive system? Because that's what they thought it only does. So, we're going to be learning today that our digestive system is a collection of systems that are working together, from churning, chopping, processing, digesting the nutrients, and then absorbing it from the digestive tract into our circulatory system, and then metabolizing. So the next chapter is going to be metabolism. All the foods that we eat, how are we going to make ATP out of them? So you must remember that for our survival, and for our reproduction, we need nutrients, and we need balanced nutrients. So if our nutritional intake, if our calorie intake is more than the calories that we burn, then that is going to be obesity. So obesity is when there is an imbalance in the nutritional intake. When the intake is too much, that is going to be obesity. And when the burning is too much, we don't have enough nutrition, the opposite of obesity is known as malnutrition. Okay, so we're going to be learning also that this digestive system is divided. So if we look at our digestive system, this is the digestive system. Since our course is anatomy and physiology, anatomy is the structure, and physiology is the function, you will see that our structure of the digestive tract is divided into an upper digestive tract. So the structure of the digestive system is an upper digestive tract, and there is a lower digestive tract. So there's an upper digestive tract that begins with the oral cavity, and the nasal cavity. Is the nose part of the digestive system? The nose is definitely part of the digestive system, because the old people who cannot swallow properly due to dementia, what do they put in their nose? Ever heard of the feeding tube? So where does the feeding tube go into?
Right here. Right in the stomach, no? Am I tripping?
You're talking about a colostomy. So the feeding tube goes right through the nose, because you see there is a nasopharynx and an oropharynx and a laryngopharynx. So the food goes right through the nose because they have a problem swallowing. So if you lost the sense of the deglutition, then food is being pumped right through the nose, but they don't put a tube. They don't put the actual food through your nose. They put a tube, and then the food is going to be propelled through the nose, and then it's going to enter into the esophagus. So, number one, the nasal cavity, that's definitely part of your digestive system. Your nasal cavity, your oral cavity. Then we have the esophagus. You have the esophagus. After the esophagus, we have the stomach. And after the stomach, there's the duodenum. And then we have the small intestine and the large intestine. You have the small intestine and the large intestine, and then you have the rectal tract. If you go beyond the esophagus, what do we have? We have the stomach, and after the stomach, we have the duodenum, and all of that is known as your upper digestive tract. This is the one in which we do the endoscopy. So our endoscopy is when we send the camera through the oral cavity, the esophagus, the stomach, and we stop here. We stop at the duodenum. That's your upper digestive tract. Nasal cavity, oral cavity, esophagus, stomach, and duodenum, which is the upper part of the small intestine. Then we said for that we do an endoscopy. And for the lower digestive tract, we do a colonoscopy, which is the remaining parts of your small intestine, and this is the jejunum and the ileum, and then you have the large intestine or the colon, and the colon is divided into the ascending colon, the transverse colon, and the descending colon, and then the rectal canal, and this is known as your colonoscopy. This is known as the colonoscopy. So our digestive tract is divided anatomically, structurally, into an upper digestive tract and a lower digestive tract. Physiologically, so for the upper digestive tract, it's very easy to remember because we only perform endoscopy on the upper digestive tract. On the lower digestive tract, we perform colonoscopy. Physiologically, we're now no longer talking about structure. Physiologically, we're talking about the function of the digestive system. And we said our digestive system, number one, is responsible for ingestion. So you ingest the food, hopefully through your mouth or the nasal cavity if you are going through some problem. You know, sometimes some of the prisoners, they do a hunger strike. So when they do a hunger strike, they want to break their hunger strikes by force. So they take them by force and they tie them to beds, and then they put a feeding tube in their nose by force, and they pump food into their stomachs. And once the food went into the stomach, then they have no choice. It will be digested, and then they will break their hunger strike. So that shows you that your nasal cavity is part of your digestive system. It's not just part of your respiratory system. So we have an ingestion, we said, through the oral cavity or the nasal cavity. So we have ingestion. Number two, what do we have besides ingestion? We have digestion. And the digestion is divided into chemical and physical digestion. There is a physical digestion and chemical digestion. So physical digestion is when you're chopping up the food physically, crushing it, grinding the food, churning the food, breaking the food into smaller pieces. And chemical digestion is when you're sending enzymes that are breaking apart macromolecules into micromolecules. So if you have a protein, if you eat a proteinaceous meal, you want to break that down into amino acids. If you ate a meal with lipids, you want to break that down into glycerol. glycerol, and free fatty acids. And if you want to break down carbohydrates, they're broken down into disaccharides and monosaccharides. And lastly, nucleic acids are broken down into nucleotides. This is not physical digestion. Crushing, blending, breaking apart the food is not going to break it down into its constituents. Only the enzymes do that. So there's an enzyme that breaks down lipids. It's called lipase. Lipase breaks down lipids. Sugars are broken down by amylase. Amylase. Proteins are broken down. The polypeptide chains are broken down by polypeptidase. Peptidase. And nucleotides are broken down with nucleotidases. So that's an example of chemical digestion. So churning, breaking apart, and crushing the food is an example of mechanical digestion. But when you use the enzymes, that is known as chemical digestion. So after we digest the food chemically, we digest the food chemically with enzymes, and don't forget the acid that is inside the stomach. This acid is going to homogenize and break apart the food bolus into smaller pieces. Number 3, we have ingestion, digestion, and after we have digested the food, we need to absorb it. Absorb. We're going to be absorbing the food from the GI, gastrointestinal tract, also known as alimentary tract. We're going to be absorbing it into the bloodstream, into your circulatory system. And then the circulatory system is going to distribute the food to the tissues so the tissues can metabolize. This food. Okay, after the absorption, we have the compaction. What is compaction? Compaction is the consolidation of water. In our homeostasis, we're very concerned with the state of water balance. You know, your digestive system is an important source for replenishing the fluids. So the food that we eat, or the water or the juice that we drink, is going to go through the digestive system. And the digestive system is going to absorb all of the water into the blood. And then we need to consolidate that water, which is a responsibility of your colon, responsibility of the large intestine. And lastly, number 5, excretion. Excretion of waste. So now we ate the food, we churned it, we digested it physically, mechanically, we absorbed the food from the intestine into the blood, and we performed compaction. We consolidated the water. So we don't only digest the food, metabolize the food products, we also consolidate the water through compaction. And lastly, it's time now to get rid of the waste. We don't want any metabolic waste that is building up. And this is known as excretion. Okay, so you see that the digestive system is an organ system that processes food, extracts nutrients, and eliminates residues, eliminates food residues. There are 5 stages of digestion. We went over that. Selective intake of food, and that is known as, what's the difference between hunger and appetite? What is the difference between hunger and appetite? So hunger is the feeling that you need to satisfy a deficiency in calories. Hunger is a stimulation that we all get because our stomach is going to start contracting when it's empty. When the stomach is empty, it's going to start contracting. Now, your appetite is different from hunger. Hunger, everybody has the same hunger. Hunger is the desire to fulfill calorie deficit. But appetite, what's appetite? What is appetite? Appetite is your choice. How do you choose to fulfill that hunger? Some people, when they're hungry, they go for salad. Some people, when they're hungry, they go for animal meat. So in the end, it's your choice. How do you choose to satisfy your hunger? That is your appetite. So the appetite is the choice of dietary intake. Choice of dietary intake. Okay. Digestion is the mechanical and chemical breakdown of food into a form that is usable by the body, and absorption represents the uptake of nutrient molecules into the epithelial cells of the digestive tract and then into the blood and the lymph. So the uptake of the nutrient molecules into the epithelial cells, this is going to be the transfer. So all of the ingestion and the digestion is a process of preparing this high energy macromolecules to enter into your tissue compartment. It is the absorption that is the most important process, because you can have all of the digested food chemically and mechanically. If you cannot absorb it, you will not be able to transfer it to the bloodstream. And if you cannot transfer these macromolecules to the bloodstream, you will not be able to fulfill the tissue with ATP. Compaction. Compaction is the absorption of water and consolidating the indigestible residue into the fecal matter. So this is the job of the large intestine or the colon. And lastly, the excretion or the defecation, which is the elimination of the useless, harmful, toxic fecal matter. So now let's go over the mechanical digestion. Mechanical digestion is the physical breakdown of food into smaller pieces. So we went over that. We said no food exists in the form of small pieces. It exists in macromolecules. So when you eat pancake, your cells, your tissue is not getting pancakes, because the pancakes are going to get shredded through your digestive tract, and then the digestive tract is going to consolidate that dietary intake that you had, your pancakes, into something that is useful. So we take macromolecules. Who are our macromolecules? Carbohydrates, that's a macromolecule. Proteins, that's a macromolecule. Lipids, those are macromolecules. Nucleic acids, those are macromolecules. So we break them down into their building blocks. These are nucleotides, glycerol and free fatty acids, proteins, and carbohydrates are going to be the amino acids. When we break down proteins into amino acids, and then the carbohydrates are going to be broken down into disaccharides. Carbohydrates are broken down into disaccharides. So, the physical breakdown of food into smaller pieces, that is mechanical digestion. It is the cutting and the grinding action of the teeth and the churning action of the stomach and the small intestines, which exposes more food surface to the digestive system. So, this is our digestive system. The oral cavity and the nasal cavity, the tongue, and the tongue is rich in those taste buds. Those taste buds are responsible for telling, is the food sour, is the food salty, is the food spicy, acidic, or hot. And lastly, there is a new test called umami. Umami is a Japanese word, but that's the taste we have for proteinaceous, a food that is rich in proteins. We call it, is going to be stimulating the umami taste buds. And once you are in the esophagus, so if we examine the esophagus, we see that is the esophagus part of the upper digestive tract or the lower digestive tract? Is the esophagus part of the upper digestive tract or the lower digestive tract? So this esophagus, so obviously you can feel yourself chewing and biting on a sandwich. But once you swallow that sandwich, once you swallow what you bit from the sandwich, now the food is gonna go inside the esophagus. And the esophagus, how does the esophagus manage? How does the esophagus manage to bring the food down? How does the esophagus manage to bring the food down? It's by those segmental bands making this, you see those bands? Making this band movement, this segmental movement known as the ripple effect. This ripple effect is how we propel the food to go down the esophagus. When we propel the food to go down the esophagus, then this is a process that is this band movement. You see this band movement, this ripple effect, is peristalsis. Peristalsis. This is a very important process that is regulated by the nervous system, because you know your esophagus is a muscular sheet and it needs to be stimulated with nerves. So the nerves, you know your nervous system, you took an A&P one, that the nervous system is divided into central nervous system and peripheral nervous system. Then the peripheral nervous system is divided into somatic and visceral, afferent and efferent divisions. And you've learned that the autonomic nervous system is a division that is, what's the autonomic nervous system? The autonomic nervous system is the system that is responsible for output, motor, efferent, visceral responses. So this autonomic nervous system is very important because the autonomic nervous system is divided into the sympathetic nervous system, and the parasympathetic nervous system. And what is the third type of autonomic nervous system, in addition to sympathetic and parasympathetic? We have sympathetic nervous system. Parasympathetic is for fight or flight. Parasympathetic nervous system is important for rest and digest. And the third one is known as the enteric nervous system. The enteric nervous system, the enteric, E-N-T-E-R-I-C, the enteric nervous system is a system that is responsible for controlling your digestive system. All this swallowing, your ability to move the muscles in your tongue, the ability to move your jaw, the ability when you swallow the food, you have peristalsis, ripple effect, segmental band movement of the food down the esophagus. Then the food is gonna get to the stomach, and the stomach is gonna churn, crush this food, gonna churn and crush the food, and then acid is going to be secreted, and then enzymes are going to be further secreted some more in your stomach and the duodenum and the remaining parts of your small intestine. And all of these processes are highly regulated by nerves. These nerves known as the nerves of the enteric nervous system. And you see here down the esophagus, this is our stomach, and then you have the duodenum, and the duodenum is a special junction because it's a junction where you have the small intestine, the gallbladder, and the pancreas. So if you look into the duodenum, that's why there's a lot of ulcers in the duodenum. And the reason is there is a junction where you have your pancreas. This is your pancreas. This is your pancreas. It's going to be secreting in this junction. And you have your small intestine. Your small intestine. This is the duodenum. And lastly, you have here the gallbladder. The gallbladder. So you see those are three inlets. Gallbladder is going to pour something in the duodenum, and food is already coming down from the duodenum. And lastly, you have the pancreas secreting the substance into the duodenum. This is 1, 2, 3, the gallbladder. Is that clear? Any question? If you're not paying attention, you really don't have to be here because I'm going to mark you present legally and I'm going to give you a 0. And I already gave a couple of you 0 last week. If you're here, you think you can be on ATI and you can be just like playing with your phone. So you can be here, I'll mark you present legally. If you get accused of something, then I'm a witness, you're here, that's the present. But as far as credit, you're getting 0. Because if you're here and you have your headphones on, you're not participating, you're not raising your hand, why are you here? Okay, but that's not for everybody. Many of you are, I know, you're participating, you're taking notes, and you're getting credit for that. I'm just talking about the small group. Okay, so if we talked about the function, let's now talk about the anatomy that makes the function possible. So if we discuss that we have churning capacity in our digestive tract, what are the tissues that allow for the churning to happen? So obviously our small intestine is not crushing that much. Is it going to have the same tissue as the stomach, who is going to be crushing and churning? So that's a very important concept. So our concept is, why did we spend a lot of time going over the function of our digestive tract? The digestive tract is going to be ingesting food. The digestive tract is going to be absorbing the food. The digestive tract is going to be digesting the food. The digestive tract is going to be secreting the food. So there's going to be special tissues for all of that. There's going to be a special tissue for absorption. There's going to be a special tissue for compaction. There's going to be a special tissue for churning. There's going to be a special tissue for secreting the acid to break down this food. There's going to be a special tissue for absorption. There's going to be a special tissue for excretion. So now let's go over the tissue. Remember, I told you from the first day, Anatomy and physiology is how we make a connection between structure and function. Remember when I said the knife is sharp because it can cut? The knife it can cut because it's sharp. The hammer is dull, that's why it's able to hammer down the nail. So if you are made of steel, that's not the end of the story. How is your structure enabling you to cut or to hammer down the nails? So now we're going to look and find out how is this digestive system able to do all of these different ingestion, digestion, absorption, compaction, excretion. We're going to be learning that there are different tissues in your digestive tract. You know when they take a biopsy? If they take a biopsy from the oral cavity, is it going to look the same like you took a biopsy from the nasal cavity? Is it going to look the same as you took biopsy from the esophagus? Is it going to look the same as you took a biopsy from the small intestine? So that tells you the tissue is different because it has a different job. It has a different function. So most of the digestive tract is going to follow the basic structural plan with the digestive tract wall consisting of layers. So the number one, the mucosa. That's a very important layer because this mucosa layer is what protects your stomach from the own acid that is going on inside it. Have you ever wondered how come you're able to digest steak? You ate steak, you ate animal meat that is very thick, but your stomach didn't. You know, steak is even thicker and stronger than your own stomach, yet your stomach is able to digest it and crush it and churn it and compact it and digest it. Why? Because the stomach has a pasty layer known as the mucosa. Stomach has a pasty layer known as the mucosa. So if you look at the stomach, there's this green layer here. You see this layer is known as, what's the name of this layer that is protecting? Let's say this is the acid, the burning acid. Why can the acid get to your stomach? This is your stomach. What's the name of this green layer that protects your, what's the name of this green layer that protects your stomach from the acid? Excellent. So this mucosa can sometimes, this mucosa gets so thin, can the mucosa get so thin, and then the patient will get with ulcer. There is a stomach ulcer or a stomach fissure, a bleeding ulcer, or a bleeding fissure. Why do we have a bleeding ulcer and a bleeding fissure? Yes? Excellent. Now the acid is gonna leak and now it's gonna burn this stomach. So our protective barrier that is helping us survive is the mucosa. What makes this mucosa get thinner and weaker? It's those painkillers. You know, people, they just take the painkillers. If you tell them don't take painkillers, they say, well, why did they make them? And they just keep on taking the painkillers. The painkillers, how do they work? Remember when we discussed in the immune system the inflammation? Inflammation is redness, heat, pain, swelling, and loss of function. This pain component is mediated by prostaglandins. Prostaglandins. Those prostaglandins, they mediate the pain by irritating the nerve endings during the inflammation. If the pain is too much, then we take the NSAIDs. Remember the NSAIDs? We take the NSAIDs. What are NSAIDs? Who remembers what are NSAIDs?
Is it like the ibuprofen?
Yeah, but what does it stand for? Very good. That's an example of an NSAID. What does it stand for? Yes, please.
Non-steroidal anti-inflammatory drugs.
Excellent. Non, N for non, S for steroidal, A is for anti, I is for inflammatory, D is for drugs. So those NSAIDs, what do? They make you feel no pain. But how does it happen? Obviously, everybody knows NSAID lower the pain sensation. But you need to know how. They stop making the prostaglandin. They block prostaglandin. So no prostaglandin, no pain. Well, there's a downside to that, because what do prostaglandins make? They make your mucosa. So you pick and you choose. You have a lot of pain, you take a lot of painkillers, you're not gonna feel the pain, but what's gonna happen to your mucosa? It's gonna get so thin and you're gonna have a stomach ulcer. The H. pylori, this deli food, the H. pylori. When you go to the deli guy and you order the deli food, and you know they have that big sign behind them, A for sanitation, A. They got A. And it's not good actually. It's not A. They're lying. Because all of this food is contaminated and rich, very rich in pathogenic infectious microbes. So when you eat it, what's gonna happen now? The H. pylori is going to degrade and break down your mucosa. Another issue is the stress. If you're the type of the person that is always stressed out, or your job, there's like some job has like a soldier, like you're in the war. Oh my God, you're so worried, you're so scared. Then the mucosa is gonna get so thin. That's known as stress ulcer. And they noticed that when they did an experiment, they brought a couple of rats, and they injected them with too much hormone. Like give one rat too much insulin. Remember, what did we say about too much something? Too much insulin, too much glucagon, too much testosterone. That's stress. You don't want, remember what we began by, too much of anything is bad. Too much food, obesity. Too little food, too minus, that's malnutrition. When you give the rats too much insulin, that's too much stress. When you give them too much estrogen, too much stress. Too much testosterone, too much stress. Too much growth hormones, too much stress. What do you think happened to the mucosa of the rats who were too stressed out? Yeah, the mucosa went down and they developed ulcers. So when you work, if you work in a GI office, you work with a gastrointestinal tract doctor, and you look when they're doing the endoscopy and you see a fissure, they used to think that the cause of the fissure is the stomach ulcer because everybody eats from the deli food, which is very contaminated, very dangerous. But actually, some people, it's the job that they have and the lifestyle that they live in. Okay, living in a dangerous place where there's like a gun violence or there's like abuse or the emotional, the domestic abuse or the war or the prison. So these people always, they have a stomach ulcer because their body is always under inflammation. They're so worried and anxious and depressed, and then they get an ulcer. Yeah.
I have a question. Like, I know this is dumb, but like, would alcohol also like make your mucosa like?
That's very true, because acetaldehyde is a metabolite that when you drink the alcohol, on the outside it's alcohol, but once it gets in the body, it gets turned into acetaldehyde. So it looks really good in the bottle, in the glass, there's light behind it, shining. But once you drink it, it's gonna turn into snakes inside, and it's gonna be, chopping and shredding your mucosa. Okay, so that's the mucosa. So now this is a definition from the superficial to deep. So now the upper layer is mucosa. Then we go below the mucosa is the submucosa, the layer below the mucosa. And then there is the muscularis externa, the muscularis externa layer. Then there is the serosa layer. So you see that these are 4 different layers only in your stomach, because your stomach is the most important organ. Your digestive tract is an organ system, a collection of multiple different organs working together. Why is the stomach so many layers? Does everybody in your digestive tract have 4 layers? Does your esophagus have 4 layers? Does the intestine have 4 layers? Only the stomach, because the stomach is responsible for crushing and grinding and secreting the acid and churning and compaction. So now let's go and look at the structures of our intestine. You can look at it superficial to deep and vice versa. You can go from deep up to superficial. So here we have the blood vessels are going to, since all of these layers, they need oxygen, they need nutrition in order for them to generate the ATP and to survive. So this is the mucosa layer. That's the innermost layer, and it is made up of stratified squamous epithelium. You guys remember the stratified squamous epithelium? So if you look at your tissue, if you look at the tissue, the epithelial tissue is always okay. So if you look at the epithelial tissue, the most important thing is the epithelial tissue is the basement membrane. If we examine the basement membrane, this is the basement membrane, the BM. Cells of your epithelia in the basement membrane, they can be found in one of 3 ways. They can be found in one of 3 ways. Okay, so the first way is you have one layer of tissue. One layer of tissue. You know the tissue has multiple cells. So this dot here represents a nucleus. So if you have one layer, that's called simple. That's a simple epithelium. Simple if you are one layer and only one layer of tissue. You cannot be more than one layer in a simple tissue. Then if you have multiple, 2 up to 20. If you have 2 up to 20 layers, if you have 2 up to 20 layers of tissue, 2 to 20 layers of tissue, that is known as stratified tissue. So stratified is 2 to 20. If you make it to 2, you're stratified. If you're only 1, you are only simple. But if you are one layer, but this one layer is kind of confusing. It's one layer, but within the one layer, you have tissues that look like this. And you have wine glass, goblet cells, goblet cells. What do we call that tissue? That is known as? I cannot hear you. No, columnar is another category. This is known as, remember, the only pseudo-stratified. Very good. So why do we call it pseudo means? Pseudo means fake. Is not really stratified. So why do they call it pseudo-stratified?
Because it doesn't, it's like all over the place. It doesn't have like one straight layer. So it's just like.
No.
No?
It has one straight layer. Please listen. Okay, everybody, please listen. Everybody, please listen. Simple layer, you have, simple tissue, you have one layer. Stratified, you have 2 up to 20. Pseudostratified is when you have one layer. It's one layer, but within the one layer, you have goblet cells and you have tissues that are touching each other and they're all scrambled, like you said, scrambled eggs. Oh, like a mixture. But how many layers do you have? One. The issue here is the layers, guys. How many layers are on the basement membrane? That's why we drew the first thing, this basement membrane. This purple basement membrane is the most important thing. This basement membrane. If you look now at this basement membrane, you see that if it's a one layer on the basement membrane, that's simple tissue. If it's 2 to 20 layers on the basement membrane, that is stratified tissue. If it's one layer on the basement membrane that is all scrambled but still one layer, we call that pseudo-stratified epithelium. So this is the basement membrane. Then is what Ariana just mentioned. Then we look at the cell type. We look at the cell type. Some cells are like an egg sunny side up. The nucleus is facing up like an egg sunny side up. Like an egg sunny side up. What do we call that type of cell? So the egg, you know the egg yolk facing up, like in the pan? Those type of cells, their nucleus face up. What do we call those cells? Squamous. Very good. Squamous. Very good. Squamous, squamous, squamous cells. Or you can have cells that are equally long as they are wide. They are equally long as they are wide. Equally long as they are wide. What do we call those? Those are known as? Those are not columnar because they are equally long as they are wide. Columnar, they are more long than they are wide. A column has more length than width, right? A column has more length, is long than the width. And the cube has equal length and width. So this is cuboidal, and this is known as columnar. This is columnar. So if you want to describe the epithelial tissue, you go simple squamous, simple columnar, and simple cuboidal. Or stratified squamous, stratified cuboidal, stratified columnar. Or pseudostratified squamous, pseudostratified, pseudostratified columnar. So if you look at the mucosa is what? Stratified epithelium. So what does stratified epithelium look like? It has 2 up to 20. It has 2, so not just 2. Some have 2, some stratified have 2, some stratified have 3, some stratified have 4. So from 2 to 20, and it's squamous. So what does that mean?
It's like the egg shape.
Yeah, it's like an egg sunny side up. So you see that the nucleus is going to be facing upward. And then there is, in the mucosa, there's a layer within the mucosa known as the lamina propria, then the muscularis mucosa. Then there's the submucosa, which is a layer with the esophageal gland. And then there's the muscularis externa, which is an inner circular layer. And there is an outer longitudinal layer. This is the muscularis externa. From the name, muscularis externa. This is the external outer muscle layer that's going to be crushing and churning the food. And lastly, there is a saran wrap on the outside of the muscle of the stomach. That's a very smooth, delicate tissue known as the serosa. And you know from the name serosa, it's a serous fluid that is rich in the water. So this is the mucosa. It's going to line the lumen. It's going to consist of an epithelium that is simple columnar in most of the digestive tract, but in the mouth through the esophagus and the lower anal canal is going to be stratified squamous. It's going to be much thicker in there because there's a lot of abrasion and there is a lot of compaction and churning that's going to be taking place in the oral cavity and in the rectal canal. The lamina propria is a loose connective tissue like a staple. It's going to hook up those layers of the digestive tract to one another so they don't disintegrate and fall apart. The muscularis mucosa is a thin layer of smooth muscle. It tenses the mucosa, creating grooves and ridges known as the rugae that enhance the surface area and contact with the food. It improves the efficiency of the digestion and nutrient absorption. There is a tissue known as the mucosa-associated lymphatic tissue. What is the mucosa-associated lymphatic tissue? MALT. You're going to see that a lot. We kind of also saw that in the respiratory system. Remember MALT? MALT. What is MALT? MALT, M-A-L-T. M-A-L-T. MALT is M for mucosa, A for associated, L for lymphatic, and T for tissue. What does that mean? That means those are the police. Those are the white blood cells. So you know the same way when you take a deep breath through your nose and through your oral cavity, the air is not sterile. The air is full of infectious pathogenic microbes. So you need on the mucosa is like glue. It's trapping, the mouse trap, the glue that trapped the mouse? Your mucosa is going to trap all of the microbes that are trying to enter and cause a disease. Same thing with your digestive system. So the air is contaminated. Food is not contaminated. Food is also contaminated. That's why you have also mucosa in your digestive tract. To trap in this mucus, trap all of the infectious microbes that are pathogenic. And within this glue, within this mucosa layer, there is a lot of lymphocytes. Lymphocytes, police cells, white blood cells who are performing immunosurveillance in the inside of this mucosa tissue to trap any pathogenic microbe. The submucosa is a thick layer of loose connective tissue that contains blood vessels, lymphatic vessels, nerve plexus, and this MALT is going to extend to the submucosa in some parts of the GI tract. What is MALT? Who can explain what is MALT? M-A-L-T. Yes, please.
You said that it was the white blood cells that fight off bacteria.
Yeah. So where do we find them? Look at the name, MALT. Mucosa associated. So they are associated in the mucosa.
Like in the stomach.
Yeah, in all of the so the stomach is one part is the stomach, but the mucosa is not only in the stomach. In the esophagus there is stomach. There is stomach. In the esophagus there is mucosa.
Oh.
In your intestine there is mucosa. In your esophagus there's stomach. I don't think that's in the esophagus there's no stomach. There's mucosa, but it's thickest in the stomach. Yeah. Muscularis externa consists of usually two layers of muscle near the outer layer. The inner circular layer, you have cells that encircle the tract. In some places, this layer thickens to form valves or sphincters that regulate the passage of material through the tract. So the outer longitudinal layer, you have cells that run longitudinally and they are responsible for the motility that propels the food and residue through the tracts. What is the mesentery? The mesentery is a connective tissue sheet that suspends the stomach and intestines from the abdominal wall and actually suspends them and holds them intact. So you know your stomach is moving. So why doesn't your stomach fall into your abdomen? What makes the stomach suspended in the air inside your abdominal cavity is the mesentery. So it's like a blinder that is holding the stomach in place from falling. Is it only holding the stomach? No, the esophagus is held by this mesentery. The small intestine is held by the mesentery, and the mesentery prevent the intestine from becoming twisted on itself. The intestines are constantly moving because there's mechanical digestion in the intestine. There is secretion of enzymes that degrade and absorb the food inside the intestine. So it's going to twist and tangle up on itself. So that's why we have the mesentery to hold it in place and not lose the tensile support and integrity that is found in the intestine. The mesentery is a single complexly folded membrane. Different regions are referred to by names of their own. So they form posterior mesentery, which is a translucent two-layered membrane extending to the digestive tract. So they come together on the far side of the organ and they continue as another sheet of tissue called the anterior mesentery. There you go. Do you now see the mesentery? So these are serous membranes that are associated with the digestive tract. The greater omentum is another example of a connective tissue that is going to suspend and help. Your digestive tract is heavy, and there is a lot of microorganisms that live in your digestive tract. Your digestive tract is not sterile. All the rest of the tissues of your body are sterile, and there's no microbes in them, like the blood, the glands, or the other organs, except your digestive tract. And in fact, the microorganisms that live inside the digestive tract, they're helping us. They're helping us to digest the food. Some food we cannot digest. The probiotics? What are probiotics? Probiotic. Pro. You know pro?
We can't digest probiotics?
No. Probiotics are bacteria that helps you digest some food that you cannot digest on your own. These are known as probiotics. Pro meaning they're good. So there's no worrying about the probiotics because they are bacteria that are helpful. Yogurt, they're found in yogurt. I don't remember the last time I had yogurt. But anyways, the yogurt.
Cranberry juice as well, or no?
Cranberry juice? I never heard of that, but maybe. But I know they're found in yogurts, and some yogurts. Is yogurt good?
Yes.
Raise your hand if you think yogurt is good. Oh, wow.
Isn't that good?
All the healthy people.
It's nasty.
Yeah. You make homemade yogurt. That's amazing.
Yeah, my
Yeah.
mom used to make it. Used to be nasty.
So the probiotics are very important. Why are they important? Because they help us digest food. Not only that, the probiotics, they defend you against other bacteria. Why? Because there's a conflict of interest. The probiotics are going to say, hey, listen, we live here, okay? So we're not going to allow any other bacteria to come in our place. So they're going to fight off that bacteria. They didn't fight the bacteria because, they love you so much and they care about you. No, they fought the bacteria so that they don't steal their block. They live in there. They don't want anybody to take it. So they actually indirectly do immune response. Okay? Okay. Now, this is very important because this brings us to the association between your digestive system and your nervous system. If you remember when we talked about the nervous system, The nervous system is very important because what is the nervous system responsible for?
Sensory perception.
Very good. That's sensory reception. Very good, Ariana. That is one of the jobs. So let's go over what makes us do, what helps us in our nervous system. Okay. Okay. So you know your nervous system is responsible for two things. Number one, you have your central nervous system, CNS. What is the central nervous system responsible for? Central nervous system is responsible for integration, processing, and control. Integration, processing, and control. So that's one system, which is your brain. That is your brain and your spinal cord. But your brain and your spinal cord are not going to be able to perform integration, processing, and control unless what? Unless there is a input signal that came to it. An input sensory signal through an afferent neuron. Are we clear? So the first stop is like some form of a receptor here. There is a receptor. There is a receptor here. There's a receptor here. There's like a chemoreceptor. There is an osmoreceptor, mechanoreceptor, photoreceptor. In the end of the day, if you are a receptor, you're going to send out an input signal. You're going to send out an input signal to the central nervous system. The central nervous system is going to process this input sensory afferent signal and is going to generate an output. If the input was sensory, what do you think the output would be? If the input was sensory, what do you think the output would be? Motor. Very good. So the output is motor. And if the sensory input was carried by an afferent neuron, what neuron is going to be carrying the output that's motor? Efferent. Very good. Efferent neuron. And please remember that this input sensory afferent neuron is going to go from a receptor, to the central nervous system. While the output motor efferent neuron is going to go from the central nervous system to who? If the input sensory afferent information comes from the receptor to the central nervous system. You see the arrow is pointing from a receptor to the central nervous system. The output motor efferent information is coming from the central nervous system to who?
Back to the...
I'm sorry? How? There is no way.
So
The
the
receptor-
peripheral nervous system?
The receptor, listen to the end. Listen to the end so you don't say something wrong. Listen. The receptor job is to do what? Is to receive sensation. It's too hot, it's too cold, is somebody pressing me, the pH too high, the pH too low, the temperature high, temperature low, there's too much glucose, too little glucose, is a sensation. The receptor only deal with sensation. So a receptor, input, sensory, afferent to the nervous system. If we go back to the receptor, it's like you call the cops and you say, hello, you call 911 and you say, I need the fire truck. And instead of them calling the fire truck for you, they call you back and they say, just go to the bathroom and get some water. And
So it'll be the effector, right?
effector, very good. So our destination here is going to be the effector, because that's why they call it efferent. Because efferent is when we are targeting the effector. The effector is usually a muscle or it's an organ. The effector is usually an organ or a gland. The effector is usually an organ or a gland. If you look at the effector, how is your nervous system divided? This portion here is called, if you have the nervous system, that is your nervous system. The nervous system is divided into the central nervous system. And what is that? What is those phone lines? That's the peripheral nervous system, the PNS. So the peripheral nervous system is, so your nervous system is divided in two halves. This is one half here called the PNS, which involves all of this: the input sensory afferent neuron and the output motor efferent neuron. That's your peripheral nervous system. So your peripheral nervous system is your input sensory afferent neuron. And it's your output motor efferent neuron. And the central nervous system is your brain and your spinal cord. Do you guys see that? Now, in your nervous system, you have to know there's one more thing that's missing. You have input sensory. When you call the cops, do you just call the cops and say, I need the fire, I need the cops, or I need the fire truck or the ambulance, or do you give your address? Same thing. If you want to communicate with the central nervous system, you have to give your address. And very interestingly, there is two addresses: visceral or somatic. So if you're dealing with tough tissue, is that visceral or somatic? Tough tissue, tough tissue, tough tissue, tough tissue, tough tissue, that is bone, muscle, ligament, bone, muscle, ligament, tendon, joint. So if we have any sensory input afferent stimulation from tough tissue, we call that somatic. We call that somatic. And soft tissue, what's an example of soft tissue? What's an example of a soft tissue? That's your lung, your heart, your bladder, and lung, heart, bladder, and stomach. Lung, heart, bladder, and stomach. That's known as visceral. So we have 4 lines now. The first line is carrying input sensory afferent somatic, and then we're gonna have an output motor efferent somatic also. Do you see that? You see the 4. Input sensory afferent somatic, and the output is going to be output motor efferent somatic, if we're dealing with tough tissue. But if you're dealing with soft tissue, you're going to have still input sensory afferent visceral. Very good. And the output is going to be output motor efferent, visceral. How many lines we have? 1, 2, 3, 4. If you call input sensory afferent somatic, you're not going to have visceral, you're going to have output motor efferent somatic. If you look now, one of these 4 is your autonomic nervous system. Which one is it of the 4? Which one of the 4 is the autonomic nervous system? One of these 4 is the autonomic nervous system.
The CNS. No?
One of these 4, 1, 2, 3, 4 is your autonomic nervous system. The autonomic nervous system is not part of the CNS. CNS is only brain and spinal cord. CNS is the headquarters you call for 911. We're talking about the phone lines. This is the peripheral nervous system. Which one is it? It's this one. Output, motor, efferent, and visceral. Input 1, motor 2, efferent 3, and visceral 4. This is known as your autonomic nervous system. Your autonomic nervous system. The autonomic nervous system is divided into sympathetic nervous system, sympathetic nervous system, and parasympathetic nervous system, and lastly we have the enteric nervous system. Is that clear? The enteric nervous system is responsible for your digestion and for your defecation and for your ingestion and for your excretion and for your absorption and for your excretion. So you see now your enteric nervous system is part of the autonomic nervous system, which is part of the output motor efferent visceral system of the peripheral nervous system. These are the 2 systems that are responsible for the neural control. There is a myenteric plexus and there is an orbac known as the vagovagal plexus. What does plexus mean? Plexus is like a braid, but not braid of hair, a braid of nerves. A plexus is a braid of nerves. So if you look in the oral cavity, you have the vestibule, the palatoglossal arch, and the palatine tonsils. If you look at the cheeks and the lips, they retain the food and push it between the teeth, and they're involved in speech, essential for the suckling and the blowing actions, including suckling by the infants. The fleshiness is due to the subcutaneous fat, buccinatal muscles of the cheeks, and the orbicularis oris muscle in the lips. The labial frenulum is a medial fold that attaches each lip to the gum between the anterior incisors. And the vestibule is the space between the cheeks or the lips of the teeth. The lips are divided into 3 areas. There's a cutaneous area colored like the rest of the face. It has hair follicles and sebaceous glands. The vermilion is a red area in this hairless region where the lips are going to meet. What's the labial mucosa? That's the inner surface of the lips facing the gums and the teeth. So if you look at the tongue is comprised of the body, this long region known as the body, and there is a root behind the body, and there are lingual tonsils, and these tonsils are lymphoid tissue where there's a lot of policing, a lot of immunosurveillance and lymphocytes. The tongue has intrinsic muscles such as the buccinator, and you see that the molars are like these are like joints. You know, the molars are anchored to the mandible, the only movable joint in your skull, and the maxilla. And there's a lot of subcutaneous fat tissue to provide cushion and support. The palate separates the oral cavity from the nasal cavity. It is a hard, bony palate, and there is a soft palate. So if you look at the dentition, this shows you these are the teeth. These are the deciduous baby teeth, and there are permanent teeth as well. The mouth has the gingiva, which covers the alveolar bone, and these are regions of the tooth that are defined by the relationship to the gingiva. There is a crown, which is a portion above the gum. The root is a portion below the gum embedded in the alveolar bone, and a neck, that is a point where the crown, the root, and the gum are going to meet. The gingival sulcus is a space between the tooth and the gum, and the hygiene in the sulcus is important for this dental health, to prevent any infections and prevent any possible infiltration. So this is the enamel. That's the hardest part of the tooth, and the dentin is rich in this connective tissue, and this is the pulp of the tooth, and this is the gingiva that anchors and stabilizes the tooth while it is binding to the gum fossus joint of the mandible. Okay, so the teeth develop beneath the gums and they erupt in a predictable order. There are 20 deciduous teeth, known as the milk teeth or the baby teeth. They erupt from 6 to 30 months. So between 6 and 25 years of age, deciduous teeth are replaced by 32 permanent teeth. So the third molars, known as the wisdom teeth, they erupt from ages 17 to 25 years. Who had a wisdom teeth? Who had a wisdom tooth? Do I know if I have wisdom tooth or not?
You don't know? What do you mean you don't know?
No idea.
Isn't it back here?
Some people it never comes out.
Yeah,
Yeah.
because if they go in straight properly, then you don't have to take them out. But if they go in like crooked, then you have to like get them.
Yeah. I have to find out. Okay, so these are the permanent and the deciduous teeth in a child's skull. And the human mouth is home to more than 700 species of microorganisms, especially the bacteria, our best friend that does not leave us alone. So a plaque is a sticky residue on the teeth made of bacteria and sugars. So this black plaque that is found on the surface of the tooth is made up of sugar. That's why they tell you don't eat sugar before you go to sleep. And the bacteria metabolize the sugars and they release acids that dissolve the minerals of the enamel and the dentin, and that causes the dental caries or the cavities. The caries are the holes that are made by the bacteria. So extraction or root canal therapy, they may be necessary if the cavity reaches the pulp of the tooth, and the plaque may calcify, causing a calculus or a tartar that would penetrate into the gingival sulcus and separate the gum and the tooth. The bacteria invade the sulcus and they cause gingivitis, which is gum inflammation. And it may progress to affect the bone, that is known as periodontal disease. What is mastication? Mastication is a fancy word for chewing. It is when we break the food into smaller pieces to be swallowed and expose more surface to the digestive enzymes. It is the first step in the mechanical digestion, and the food is going to stimulate the oral receptors that trigger an involuntary chewing reflex. It's the tongue, the buccinator muscle, the orbicularis oris. What's the difference between the orbicularis oris and the orbicularis oculi?
One is around the mouth, the other one's around the eye.
Very good. Excellent. Which one is around the mouth?
The orbicularis oris.
Very good. And around the eye is the?
Oculi.
Excellent job, Ampolo. Very good. So there are intrinsic and extrinsic salivary glands. This saliva is very important for the lubrication of the food, and it's rich in hydrolytic enzymes that would kill any microbes that were found in this food. What happens to the salivation when you're dehydrated? Let's say you were running, and while you were running, what happens to the saliva? Will you be able to eat a sandwich right off the treadmill?
No.
You're just running, and then you're like, you know what, let me just go eat a sandwich. That never happens, because saliva is going to be shut down, inhibited, because saliva is 99% water. It's 99% water. So this is the microscopic anatomy of the salivary gland. They secrete the saliva in a tunnel, and this tunnel is known as a duct, and this salivary duct is going to allow for the passage of this saliva into the cavity, in the oral cavity. There are extrinsic salivary glands that secrete about 1 liter to 1.5 liters of saliva per day to keep your mouth in a state of lubrication. And this actually comes from your brain. Your brain is the one who tells the saliva to secrete the saliva. So the salivary nuclei in the medulla and the pons are going to respond to signals generated by the presence of food, and is excited by tactile pressure and taste receptors, and salivatory nuclei receive input from higher brain centers, as well as odor, sight, or the thought of the food is going to stimulate salivation. The salivatory nuclei is going to send signals by way of the autonomic fibers in the facial and the glossopharyngeal nerves to the glands. The parasympathetic fibers are going to stimulate the glands to produce an abundance of thin, enzyme-rich saliva. And the sympathetic cavity is going to stimulate the glands to produce less and thicker saliva with more mucus. So when it comes to swallowing, what's another big fancy word for swallowing? You know, another fancy word for chewing is mastication. What's a fancy word for swallowing? Deglutition. Deglutition. Yeah, deglutition. So when it comes to swallowing, there's an oral phase where the tongue is going to form a food bolus and pushes it into the laryngopharynx. Then there's a laryngeal phase, and that one is involuntary. The first phase you started, that is very voluntary. But the pharyngeal phase is involuntary and prevents the food and drink from re-entering the mouth or entering the nasal cavity. Over there, breathing is suspended, and the infrahyoid muscle is going to pull the larynx up to meet the epiglottis and cover the laryngeal opening. The pharyngeal phase is a phase where the palate, the tongue, the vocal cords, and the epiglottis are going to block the oral and the nasal cavities and the air and the airway, while the pharyngeal constrictors are going to push the bolus into the esophagus. So the esophageal phase is a wave of involuntary contractions called peristalsis, mediated by your brain, and peristalsis is coordinated by both swallowing center and myenteric plexus in the esophageal wall. The esophageal phase, these are the segmental bands we went over earlier. Peristalsis drives the bolus downward, and relaxation of the lower esophageal sphincter is going to admit it into the stomach. Okay, so let's stop at the stomach and let's do the microscopes. Please take a 10-minute break.